All right, so let's talk about pH homeostasis. All right, so when we talk about pH homeostasis, we're talking about the pH within the extracellular fluid, which is basically plasma. So the plasma range of acid, or being its pH, the pH range in plasma ranges from about 7.38 to about 7.42. So we say an average of about 7.4. So up here it's a little basic, down here it's a little acidic. So it is very important that the pH doesn't go outside of this range. pH has a huge effect on proteins. Proteins are denatured by acids, and then they can't function. So when we're in acidosis, that's going to depress I can't even spell a simple word like depress. I need to hang it up. Okay. So it will depress the nervous system. So it will depress the nervous system, and eventually you would end up in a coma. That would be bad. When we're in alkalosis, so this would be acidosis. So too basic would be alkalosis. So basic or alkaline. And that's going to cause hyper excitability, which will result in cramping. Okay, so neither one is great, right? So pH is pretty important, and there are 3 ways that the body maintains pH or handles acid-base balance. The first one we talked about in AP1, and those were buffers. So the main buffer for the plasma is the bicarbonate system. Okay, so if you remember, there was this little equation we've looked at several times where we have carbon dioxide plus water yields H2CO3, which is carbonic acid. And that can be broken down into hydrogens and bicarbonate. So this part right here is the buffer. So if we have too many hydrogens, we can bind them up by attaching them to bicarbonate to make carbonic acid. If we don't have enough hydrogens, we can break that apart to bring it to yield hydrogens and then bicarbonate as well. So remember, pH is about hydrogen ion concentration, not really about hydroxyl, which is the alkaline part of this. Okay, it's about hydrogens. It's how many hydrogens we've got. Okay, so that's the buffer. This is fast. It's fast and immediate. It happens like instantaneously. Okay, the second way that we deal with acid-base balance is the respiratory system. So we talked about that a little bit with the respiratory system. So if we have a lot of hydrogens, we can make carbonic acid, and then we can break that apart into carbon dioxide and water and then blow that off. Okay, we can just breathe it out. So about 75% of pH homeostasis occurs by the respiratory system. It's slower than the buffer, but it's still pretty fast. Okay, so the third way is through the kidneys. The kidneys are the slowest to react, but the most powerful with its effect. Okay, the kidneys can reabsorb bicarbonate. It can make bicarbonate in the kidney tubules, utilizing that equation. And it can also secrete and retain hydrogens. Okay, so the kidneys have the ability to dump hydrogens in the urine, put it into the filtrate, and let it go into the urine, or it can reabsorb it and put it back in the blood. Okay, so we've already talked about the first two, so we're going to talk about exactly how the kidneys deal with pH homeostasis.